Day guys, so my topic is all about correlation coefficient. What is correlation coefficient? It's a statistical measure of the degree to which change to the value of one variable predict change to the value of one another. So this is commonly used for statistic or uh, measuring the status of the sales. Example, the sales of the ice cream or the demand of ice cream. It depends on the temperature or how hot is the climate right now or how cold is the climate, the weather, I guess. So how to compute the correlation coefficient of the person correlation coefficient. So this is the formula. R is equal to n times to the sum up of x and y minus sum of x times sum of y over square root n sum of x squared minus x minus sum of x to the power of 2 and sum of y squared minus sum of y to the power of 2. So this is my example, the table or example of my table, how to compute or to get the what we call the correlation. So I have six subjects. So this I have six subjects. Age. So age is the x, yeah, and then locus is the y. So I have a sample of a table. So how do I get this x and y? So first thing to do is um okay, so first thing to do is to make a chart. Use the given data, so this is it, the given data, and add the three more. So we should add in the table the x and xy, x squared and y squared. And then next is to take the square. So how to compute the x and y, where did I get the value of x and y? So to get the value of x and y, we should multiply the x or the age to glucose or the y value. So 43 times 99 is equal to 4,257 and so on. So next is how to compute the x squared value. So uh, to get this is to multiply or get the square root or take the square of x column. So and then we should get, so 43 times 43, wait, 43 I guess, I think, okay, 9 12 12 oh no, wrong, oh right, 12, and then 16, 15, then that's it, 1849. So 1849 is the value, and so on to compute, same as in the y squared. So we should multiply it by self, or we should get the square, so we can get the y square, y squared. So we should sum up this to get the sum up of x and y. We should sum all the values in our table. So the sum up value of our table is this 427, then no, 247, so sorry, 247, then 486, and then 2485, and then 11,409 and 40022. So we get the sum or the total of all the table in our the all value in our tables. So now, to execute these all values, we will use our formula, the formula of coefficient. So n is the subject. So we have 6 values or 6 subjects in our table. So 6 times to the sum up of x and y to 20,485 minus to the sum of our x value 247, and then the sum of our y, the 486, over square root of another, we had n, so 6 multiply the sum of the x squared, so 11,409 minus the sum of our x value to the power of 2, then 6 sum of the y squared minus to the y value. So the result is for 0.5298 or 52.98%. So as we can go, so how we compute it? So first is we should multiply 6 times 20,480 45. So now the value of that is 12,990 910. Then multiply 427 and 247 and 486. So the value is 12,0042, and then we should subtract it. So that's it. Oh my god, sorry, I am in. And then the next is multiply again this 68454. So less, so 247 times 247 is equal to 61009. Then sorry for my nose is so annoying. Okay, then another one is multiply this into okay 240,132. Then less again, we should multiply by it also for 486 times 486. So the answer is okay 236196, and then we should subtract so 2868, then oh my god, my nose. 7445, sorry for that, 7745
3 okay 3936, and then multiply this. So the next is 2868. So the answer is 29303,520. So the square root of 29300,550 is, oh my god, 2868. The square root of 29303,520 is 5413.2726. So 2868 divide to 5413.2729. So this is the answer. Okay, and then so the range of the correlation, or the range of our correlation coefficient, is from -1 to 1, and our result is 0.52 or 52.98%, which means the variable have is a moderate positive correlation. That's all, guys. Thank you.